Hello everyone. In this video, we are going to discuss how to change the order of integration in a double integral. So what do we mean by changing the order of integration? Suppose this is your given integral. Okay, integral a to b, then integral g1x to g2x for the function fxy dy dx. So we know that in this case the order of integration is, yes, it's dy dx. Means first we should integrate with respect to y and then with respect to x. And the limits are, for y, it's from g1x to g2x. These are the limits for y. And for x, the limits are from a to b. Okay, so changing the order of integration means rewriting this integral in this form: integral c to d, integral h1y to h2y, fxy, dx dy. So what happened here? Here you are first integrating with respect to x and then with respect to y. So in this case, the order of integration becomes dx dy. And the limits again get changed. X varies from h1y to h2y and y varies from c to d. Note that the function that you are integrating remains same. Also, in this changing the order of integration, the region bounded by the curves x and y will be the same. Okay. Why we are doing this? Sometimes it makes the complex integral easily solvable. Okay, so that's the reason we make a use of it. Let's see if we have to change the order of integration of this integral. So how we are going to work. So first of all, we have to check what is the current order of integration. As it says dy dx. So the current order is dy dx. Y first and then x. Okay, then we need to know the limits. So these are the limits for y, these are the limits for x. So let's write the limits. Here y varies from x to y equal to 2 and x varies from 0 to x equal to 2. Now, we want to change the order of integration. So to change the order of integration, it means it's dy dx. The changed order should be, that we want, should be dx dy. Now to change the order of integration, first we need to know what is the region bounded by these curves. So this is the region that we denote by R. So for that we have to draw the graph of these lines. Okay, because each one of them represents a straight line here. So let's draw the lines. So for that, let's work on it. So x equal to 0, x equal to 2, y equal to 2. You know it directly. You may, suppose if you don't know how to plot this y equal to x, then what you can do for y equal to x, prepare a table. Okay, substitute the different values of x to get the different values of y. So if you substitute x equal to 0 here, you will get y as 0. If you substitute x is equal to 1, you will get y as 1. Similarly, if you use x equal to 2, you will get y also equal to 2. So y equal to 0 is just a straight line joining the points 0, 0, 1, 1 and 2, 2. Okay, so let's plot the graph. So when we draw the graph, this is the x-axis, this is your y-axis. Okay, this is x-axis, this is y-axis. We know that as x-axis, y is equal to 0. And at y-axis, x is equal to 0. Now, starting with this, let's say you have the point here 1, 2, 3, 4. We will put the points accordingly here on the y-axis. 1, 2, 3. Okay. So 0, 0, 1, 1, 2, 2. These are the points on the line y equal to x. So 0, 0 is this point, 1, 1 is this point, and 2, 2 is a point over here. Now we draw them by joining a straight line. Okay, so this is your line y equal to x. So we plotted this. Now we have to plot y equal to 2. So at this point y is equal to 2. So y equal to 2 is a straight line. Okay, passing through this. So this is y equal to 2. This is done. Now come to the x. Why we started with y? Because we are integrating first with respect to y. So let's do that. Now x equal to 0. X equal to 0 is nothing but the y-axis. X equal to 2. X equal to 2 is here. So it will be a straight line. So this is x equal to 2. Now you need to know what is your region R. So to understand this region R, what you need is check the limits. Y, it varies from x to y equal to 2. On this line, y is equal to x and y equal to 2 is here. So it means first you are integrating with respect to y. So it means your movement is from down to up because y equal to x is this line, y equal to x is this line and y equal to 2 is this line. Okay, so this is your region. Okay, and x varies from 0 to 2. So here x is 0 and here x is 2. So your region is this. You see, this is your region R. So what you have seen that when the order of integration is dy dx, it means you will have a vertical line. First, like y is varying vertically. Now you want to change the order of integration. You need dy dx, dx dy. So it means you need the variation first horizontally. Okay, so horizontally if you move in this region, it means you start from here and you reach here, correct? This will be the movement along this arrow. So at this point, what is the value of x? X is 0. So let's write down the new limits. So here, since you are moving horizontally and horizontal movement x varies, so limit starts for x first. X equal to 0 to x equal to a point on this line. On this line, what is the value of x? It's y. So x equal to y. Okay, and then this region is now, it's from bottom to top. So here the value of y is 0. And at this point the value of y is 2. So limit for y is from 0 to y equal to 2. So these are your new limits. So after getting the new limits, your new order of integration becomes dx dy and these are the limits. Okay, so what you have, the same function, this x varies from 0 to y and y varies from 0 to 2. So first you are integrating with respect to x and second with respect to y. So this is the thing you have to do in each question which involve the or changing the order of integration. So let's see an example where after changing the order of integration, we will solve the question as well. Okay, so let's take this example. In this current example, what you have, the order of integration is dx dy. So the current order of integration is dx dy. Means first x and then y. And what are the limits? Let's write down the limits. What are the limits for x? Yes, x varies from x equal to y to x equal to 1. And y varies from y equal to 0 to y equal to 1. Okay, so you need the new order. The new order of integration should be dy dx, correct? Now you need the limits for that order as well. So to find those limits, first you need to draw the graph. So you know that y equal to 0, y equal to 1, you can easily draw. And we just saw how to plot x equal to y. So let's draw the graph and find the region R. So let's assuming that this is your x-axis, this is your y-axis. Here y is equal to 0, here x equal to 0. Let the points be 1, 2. Say here 1 and 2. Okay, x equal to y. So similar to the previous question, x equal to y gives you these points. X equal to y give you the points 0, 0, 1, 1, 2, 2. Okay, so plotting these points here, 0, 0, 1, 1, and 2, 2, and joining the line through all this point. We just make a straight line. Okay, so this is y equal to x. Now x equal to 1. At this point, x is 1. Okay, so it will be a straight line. Just a bit. It should be a straight line. Plotted something wrong. Similarly, here you have y equal to 1 and this is y equal to 0. This is your line x equal to 1. Okay, now we have to check what is the region. So here, since first the variation is in the limits of x, so x varies from x equal to y to x equal to 1. So it means x equal to y is this and this is x equal to 1. So it's the variation first in x. So it means first the movement is horizontal. Okay. And then we have to make it vertical. So here the region R is this one because x varies from y to 1 and y varies from 0 to 1. So this is your region. When you are changing the order of integration, so you are looking for the vertical movement first. Okay, so when you look the vertical, along vertical direction, what varies? Y varies. So at this point, what is the value of y? 0. And on this line, what is the value of y? X. So the new limits will be for y equal to 0 to y equal to x. And then this is the region. X varies from 0 to 1. The limits for x will be from 0 to x equal to 1. So now we rewrite our integral. Our given integral was from 0 to 1, y to 1, e power minus x squared dx dy. And the new integral become after changing the order of integration as limits from y, 0 to x from 0 to 1, e power minus x squared dy dx. Now, if you look at these two integrals, this integral is a bit complicated to integrate because you have to integrate e power minus x squared with respect to x. Okay, whereas in this case, when you are integrating the innermost integral, you are integrating by considering x as a constant. So you can easily integrate this with respect to y. Let's see how we complete this question. So to integrate this first, what we will do, we will solve the inner integral. We're going to solve it as an iterated integral. So this integral is from 0 to x e power minus x square dy. Now dy means you are integrating with respect to variable y, and you are going to treat the other variable x as a constant. Now this being constant, so you are integrating with respect to y. You don't see any y. There is no y. So it means what you will do, what will be the integral? E power minus x squared times y. Because if there is no y, you must multiply with y. So y is from 0 to x. Substituting the limit. E power minus x squared, this gives you x minus 0. So in short, you're left with x e power minus x squared. Okay. Now, what you see, you finish integration with respect to y. So you should not have any y term here. It shows that you are doing your calculation correct. It's a way of checking. Now, use this value in the leftover integral. It is 0 to 1 x e power minus x squared dx. Now here what you see, it's a product of two functions. It's not possible to merge them together. So in this case, you go by integration by substitution or integration by parts. Always check for substitution first. If substitution doesn't work, then only go for integration by parts. So let's see what you can use. Now, if you look at this function, it is e power minus x squared. Generally, you have seen that the integral of e power x or e power 2x like that. But here it is x and its power again. So this will not allow you to use these rules directly. So what you do, make this thing as a substitution. So let's use u is equal to minus x squared. To check whether your substitution is correct or not, do the derivative. Derivative of u with respect to x, it is minus 2x. Okay, so here if you see, you will find that what you got after derivative, the variable is x, which is available here. So it will get cancelled here. So it means you are doing correct. So next, find the value of dx, which is du over minus 2x, which is dx. So now using this substitution here, what we will get? I'll first see to solve the indefinite integral because either you change the limits and then integrate, otherwise you just integrate, substitute back and then keep the same limit. Okay. So what we are doing, x is same, e. In place of minus x squared, we are using u. In place of dx, we can substitute du over minus 2x. Okay, what we can cancel? X and x. So we left with integral e power u, and this is minus 1, minus 2 in the denominator. So it's same as minus half du. Now here you can use this rule. Okay, so this gives you minus 1 by 2 eu. And substituting back, it gives you e power minus x squared. Okay, now you have the limits. Using your limits, what you will have, your value is minus half e power minus x squared, and the limits were from x equal to 0 to x equal to 1. So what you are going to do, you are going to replace this x one time by 1 and then by 0 to get your final answer. So this gives you minus half e power minus 1 square minus e power minus 0 square. Okay, so this is minus half. Note that this minus x squared, this is minus x squared. It is not same as minus x and its square. Okay, So negative sign will be there. Okay, so it gives you e power minus 1 minus e power 0 is 1. So this is the value of your integral. Okay, we will see another example in another video.